All right, looks like it's a good time to start talking a little bit more about our algebra of functions, and I promised you in our last video that we would do a more complex example. Now this one's a pretty good one. Here I've given us that our f of x is going to be 4x minus 3, and our g of x is going to be 4x squared minus 7x plus 3. So once again, if we are adding functions, I'm going to do this as f plus g of x, which is just this f of x plus g of x. That's going to be that 4x minus 3 plus that 4x squared minus 7x plus 3. So with this, we could see I could do something like, I could just add straight across. This addition means that I'm not going to change any of these signs here. It looks like I will have 4x squared, and then 4x minus 7x would be minus 3x, and then minus 3 plus minus 3 and a positive 3 would be 0. So my f plus g of x would just be 4x squared minus 3x. I also want to say, with this we could do something a little bit more exotic if we wanted to. I could say, what happens if I did something like 2f plus 3g of x. Oops, I don't know why I'm saying g. That means I would take, if you can imagine that would be 2 of these f of x's plus 3 of these g of x's. So my f of x is 4x plus 3, so it's going to be 2 times my 4x minus 3, I should say. My g of x is that 4x squared minus 7x plus 3. And now when I do this, I'll end up with 2 times 4x is 8x. 2 times minus 3 is going to be minus 6. I'll move on to my second kind of larger term here, and I'll distribute this 3 here. So 3 times 4x squared is going to be 12x squared. 3 times minus 7x is going to be minus 21x. And then 3 times 3 is plus 9. And then, just to finish this up, we're going to go ahead and combine our like terms. I will have 12x squared, 8x minus 21x, looks like that's going to be, what is that going to be, 13x? Sorry, minus 13x. And then minus 6 plus 9 is going to be plus a 3. So we can see how we can sort of play with this notation a little bit to get some more interesting results. Anyway, let's continue on with this though. And we've done addition. Let's go ahead and do our subtraction one. So here I'm going to do f minus g of x, and this is going to give us that 4x minus 3 minus our 4x squared minus 7x plus 3. So once again, we need to watch our signs. We're going to distribute this negative in here, which means that all of the signs in this second set of parentheses are going to change. So I'll have 4x minus 3 minus 4x squared minus a minus is plus 7x minus a minus, or minus a plus is going to be minus 3. So now I've got a negative 4x squared. 4x plus 7x is going to be plus 11x, and then minus 3 would be minus 6. All right, that's pretty straightforward. Let's do our multiplication. If I'm doing f times g of x, once again, this is just multiplying my f of x times my g of x. And this is, once again, this is going to be different than composition. So here we're just multiplying 4x minus 3 times that 4x squared minus 7x plus 3. So to start with, remember, here I've got just polynomial multiplication. I'm going to just distribute this first term into this set of parentheses. So I'm going to have 4x times 4x squared is going to be 16x cubed. 4x times minus 7x is going to be minus 28x squared. And then 4x times 3 is 12x. Now we distribute this negative 3. So now I'm going to have minus 12x squared plus 21x and minus 9. I'm distributing this negative 3 in through here. So I've got 16x cubed. 28 minus 12 is going to be minus 40x squared. It looks like it's going to be plus 33x and then minus 9. Last but not least, we're going to do our division. F over g of x. And here, this is going to be 4x minus 3 over 4x squared minus 7x plus 3. Again, that's just this f of x function divided by my g of x function. Well, if I could reduce this, I will. And it's a little hard to tell if I could actually do something with this and maybe factor it. Here I'm going to say, well, 4 times 3, just thinking about this, I could say, what's going on? That 4x squared minus 7x plus 3. 4 times 3 would be, of course, 12, and actually negative 4 plus a negative 3 would be a negative 7. So I could split this up and say, oh, that's like 4x squared minus 4x minus 3x plus 3. And I'm factoring by grouping here. So here I can take a 4x out. That'll leave me with x minus 1. I can take a negative 3 out, leaving me with x minus 1. So I've got, x minus 1 times 4x minus 3. So this is just my little thought bubble over here, my scratch work. So that means I can factor this. So I've got 4x minus 3 over x minus 1 times my 4x minus 3. And then I get to reduce. So here I've got 1 over x minus 1. One important thing I want to note here is that even though this factor in my denominator goes away, I have to consider both of these things when I look at my domain. So I'm going to say that for my domain, I have to include my original expression. That's when finding your domain. So we might only want to include this x minus 1, because I know that I can never have a 0 in my denominator. I could say that, okay, x minus 1 cannot equal 0, so I could see that x could not equal a negative 1. But from here, I also have to say, so there's this factor, I also have to say that my 4x minus 3 also cannot equal 0. So I couldn't have 4x equal to 3, or x could not equal 3/4. So I have two domain restrictions here. Even though my simplified expression only has one factor in the denominator, I have to remember that even something like 0 divided by 0 is still illegal. Alrighty, that's all I have for right now, and I will catch you in the next video.